AB Calculus Note Card 11, Instantaneous Rate of Change. This is the 11th video lesson in the series that is inspired by Stacy McMullen and her development of the note card system for basic calculus. So what we have is instantaneous rate of change. And this goes back to the definition of a derivative, what these expressions look like here. And the limit as h approaches 0 of f of a plus h minus f of a over h is the instantaneous rate of change with the acronym IROC of a function f at x equals a. F prime of a is the slope of the tangent line to f at x equals a. And so it's back to our roller coaster analogy. If you have a roller coaster here, and at a point, the slope of that tangent line is the instantaneous rate of change. And you can get to exactly what that is by shrinking the intervals around that point of tangency until you have exactly that point of tangency. We've talked about this in earlier note cards. So let's go do some applications of this, and we're going to be using our derivative rules and also our understanding of these definition of a derivative looking equations. 1. What is the instantaneous rate of change at x equals 2 of the function f given by f of x equals negative x cubed plus 3 over 5x squared minus 4x? And my first suggestion here is to go to what I call a calculus-friendly version of this function. So we're looking for rational powers. So we have negative x cubed. That comes as stated. And then we have plus 3/5. And down here in the denominator, we have x squared, which using the rules of exponents is going to be x to the negative 2 power. And then we have lastly minus 4x. And now we can find f prime of x by using the power rule. And then we have, for this, we have negative 3x squared. And now for this second term, we're going to add negative 2 times 3/5. And then we have x to the power of negative 2 minus 1. So we're going to have x to the negative 3rd power. And then this last minus 4x is going to, the derivative of that is going to be minus 4. And simplifying, we'll say f prime of x is equal to negative 3x squared. And now we have, for the second term here, we have plus negative 2 times 3, so that's going to be minus 6. In the denominator, we have 5. And we're going to have x to the 3rd power down here, and then minus 4. And now for plugging in x equals 2, we're going to say f prime of 2 is going to give us our instantaneous rate of change at x equals 2. So plugging in, we get negative 3 times 2 squared minus 6 over 5 times 2 cubed minus 4. So I think we're going to be looking at a simplifying exercise here shortly, okay? F prime of 2, and just simplifying, I'm going to go all out here. So we got 2 squared, which is 4 times negative 3, so we have negative 12. And then this next fraction we have here is 6 over, and what do we have in the denominator? We have 5 times 2 cubed, well, that's going to be 8 times 5 is 40, minus 4. And so 6 over 40, I believe, simplifies to 3/20. So we have f prime of 2 equals negative 12 minus 3/20 minus 4. And we can change all these to 20ths. Okay, f prime of 2 equals, that's going to be 20, it's going to be negative 240 20ths minus 3/20 minus a 4 is going to be 80/20, right? So we have negative 240 minus 3 minus 80, so we're going to get negative some great number, excuse me, negative 323 20ths. Okay, so that's the instantaneous rate of change at x equals 2. Okay, 2, at a time t seconds after it is thrown up in the air, the position of an orange is given by s of t equals negative 4.9 t squared plus 25t plus 3. Find s prime of 4 and interpret the meaning of the value you found. So I'm going to write this here. S of t is equal to negative 4.9 t squared plus 25t plus 3. Is there anything strange about this function? Yes. Feet. Okay, position due to the force of gravity is going to be usually mentioned as negative 16 t squared. So negative 4.9 makes more sense in meters, but we're going to let that slide. I've told Stacy about that. Okay, S, let me write it like this. V of t, or the velocity, is equal to S prime of t, and I've given a hint of what this is. So we have negative 4.9 times 2, so it'll be negative 9.8 t, and the derivative of 25t is going to be plus 25. And find s prime of 4. S prime of 4 is equal to negative 9.8 times 4 plus 25. And negative 9.8 times 4 is going to be negative 39.2 plus 25. And that's going to be what? 14. Negative 14.2. And time t seconds, position of oranges in feet. So that's going to be units of feet per second. Okay, because the rate is the first derivative equals derivative of position. So this is going to be velocity of orange at t equals 4 seconds. Okay, so that would be interpretation amount. So let's go look at the next problem 3. If f is a differentiable function, then f prime of a is given by which of the following? Now I'm going to cheat a little bit with this. because you want to get 0 over 0. If we go back to this instantaneous rate of change, the initial number 1, we see what these things should look like. And coming back here, it looks like they are in evidence both in Roman numeral 1 and Roman numeral 2. But this x equals a doesn't do anything with this here, with this h, doesn't do anything to get the denominator to 0. So that's not going to work out. So we're looking at 1 and 2 only. Anyway, this is what I have for you today in this note card. Good luck, and thanks for viewing.